Okay, continuing with 2.5. I had a diagram up there. Let me redraw it. But now that we went over the basic format of the two-column proofs, we want to actually prove something. Here's what we're ultimately trying to build to. At least to begin with, it'd be pretty difficult for me to say, well, write your own two-column proof for given angle 1 is congruent to angle 2, and try to prove that angle 2 is congruent to angle 1, or any other two-column proof. So we're going to try to build up to you writing your own two-column proofs. To begin with, we'll go over like filling in certain parts of already constructed two-column proofs, but eventually what you're going to have to do is write your own two-column proof. So we might as well go over an example on how to do that. So as I mentioned, for any two-column proof, you're always given something. In this case, angle 1. Remember, this little symbol is congruent to angle 2. And then you want to prove that angle 2 is congruent to angle 1. And then you have this diagram as well. So I'm going to make my two columns here. Just a big T table. How we label it in part 1. We have our steps, or I said they could also be referred to as our statements. So yes, you should be labeling the headings in your T table or labeling your two columns. And then you have your reasons, or again, you could also refer to those as justifications. It doesn't matter. There's always a first statement and a first reason, even though the number of statements and reasons as far as the total number might be different. But the first statement here, angle 1 is congruent to angle 2. The first reason is that's what was given. So the first reason should be given, like we went over for your basic format of your two-column proofs. Now, here's what you need to be able to figure out. And here's what makes just proofs in general, let alone two-column proofs, what I would consider pretty difficult. You have to have every little statement in there. You have to have them in the correct order as well. So just think about what it means if angles are congruent. If angles are congruent, then the measures have to be equal. So if angle 1 is congruent to angle 2, then the measure of angle 1 has to equal the measure of angle 2. Oops, that should be angle. And then the reason, so again, your reasons or your justifications, you could use facts, you could use definitions, you could use properties. You just need to figure out what you're doing from step to step. Okay, if this was already set up for me and I didn't write on my own, the measure of angle 1 is equal to the measure of angle 2. Basically, the reason for statement number 2 is what you're using from one statement to another. So how do you know if two angles are congruent, that the measures are equal? Is basically the reason that you're looking for or that you need to write. So by the definition of congruent angles, if two angles are congruent, then their measures are equal. That means you can go from statement 1 to statement 2. The definition of congruent angles, that's the reason that the two measures are equal. You could also just say like definition of congruence. I'm going to be as specific as possible. Definition of congruent angles. And then here's what I always say as well, not just for two-column proofs, but for any proofs. You always want to look behind. You always want to look ahead. See what you've done. See where you're going. You have to see what you've done to be able to figure out the reason that you're using. You have to see where you're going as far as what you're trying to prove to see what you would want to write next. I'm trying to prove that angle 2 is congruent to angle 1. And some of you might just look at this and say, well, if angle 1 is congruent to angle 2, it just makes sense that angle 2 is congruent to angle 1. What do I have to prove? And again, you need every little statement or step. So I'm trying to prove that angle 2 is congruent to angle 1. I have the measure of angle 1 is equal to the measure of angle 2. So from there, I can just switch these sides here. Here's where you should have watched the videos for, I believe it's 2.3. But the measure of angle 2 is equal to the measure of angle 1 is what it should be. Okay, now that we have the measure of angle 2 is congruent, or is equal to the measure of angle 1. So notice from statement 2 to statement 3, or step 2 to step 3, I just switched sides here. You have to think about like what property basically says you can switch sides of anything. If A equals B, then B equals A. If the length of AB is equal to the length of CD, then the length of CD is equal to the length of AB. So what says that is specifically the symmetric property of equality. Again, from a previous lesson. And then statement number 4, we're not done yet, because here's what we're trying to prove. Angle 2 is congruent to angle 1. Like, we're close. The measure of angle 2 equals the measure of angle 1. I don't have written exactly angle 2 is congruent to angle 1. If the measure of angle 2 is equal to the measure of angle 1, then what that really means, or what we should be able to conclude, is angle 2 is congruent to angle 1. And what says that we could do that is kind of like statement number 2, not kind of like statement number 2, reason number 2, the definition of congruent angles. If two angles measures are equal, then the angles are congruent. So the definition of congruent angles. So like I was saying in part 1, we have 4 statements. We also have 4 reasons. But just because we use definition of congruent angles for a reason once doesn't mean we can't use it again. So there's still the same number of reasons as the number of statements, but we use the exact same reason twice. And you could do that. This is exactly what we were trying to prove. So that's the entire 2-column proof.